So we're going to be doing trig integrals, and the first part before you start it is you need to know the formulas and what they equal. So we're going to start off with cosine. So you know the derivatives is when you do cosine, when you're doing the derivative sine, it's cosine, but for integrals it's the opposite. So when you're taking the integral of cosine x, it's going to be sine x plus c. It's not going to be negative because you're going the other way. But for sine x, when you take the derivative of that, it is going to be negative cosine x plus c. And one thing to remember is that whenever the integral is going to be a cosine, cosecant, or cotangent, it's going to be negative. It's always going to be negative. So remember that c is negative. And so for the other ones, it's the integral of secant squared x dx is tangent x plus c, and then when you do secant tangent x dx, it's secant x plus c. Make sure you have the plus c at the end if you're not looking for a value and you're just trying to find the equation. So we're going to start off with a problem. The problem is going to be 3 over sine squared x dx. So the first thing you're going to do is you're going to pull out this value right here, and that's going to be 1 over sine squared x. Now when it becomes 1 over sine squared x, you want to simplify it, so it's going to be 3 integral of cosecant squared x dx. Now that's a lot more easier to solve than it would be that. So as we know for our little chart, the derivative of cosecant squared x dx is negative cotangent x. So it'll be negative 3, because you got to pull this down, cotangent x plus c. You always have to make sure you have that plus c if you're not solving for anything. Okay, we're going to do a problem from use substitution. It's just like y'all done before. It's not anything fancy. So our problem is going to be the integral of 9x plus secant 5x plus tangent 5x dx. Now your u is going to be 5x. So we're going to write off to the side is 5x. And now you know your du is the derivative of u, so you know that is going to be 5 dx. So what you're going to do is...
What are you going to do? She's thinking.
You know that these are all your u's right here.
Of course.
And then... so it's going to become 9x dx. You're going to separate these variables. Plus, you're going to plot a 1/5. And it's going to become secant of u tangent of u du. And then you're going to do 9 over 2 because it's x squared. You know that you have the x, you have to take the antiderivative of that. Plus 1/5 of secant u, as you know. That's what it equals for secant x tangent x. So secant u plus c, so it's 9 over 2 x squared plus 1/5 secant 5x plus c. So you're going to take, we have to make sure you remember that when you don't have that variable of du on the inside, that you pull out the opposite of it on the outside of the integral and then multiply it later on.
What was that?
I have no idea.
Alright, and now we're going to do FTC, the fundamental theorem of calculus. Now the formula for that is integral of b of a f of x dx, which equals f of b minus f of a. So we're going to do the first one, which is, our first example is going to be 0 pi over 4 secant squared x dx.
Oh, this one's a great marker.
So you know the derivative of secant squared x is going to be tangent x. Now because you have values to solve for, you're not going to have a plus c. So this is going to become 0 pi over 4 tangent x. Now you're going to plug it in. It's going to be tangent sorry, pi over 4 minus tangent of 0, like that. Gracious. This, if you look in your unit circle and everything, is going to equal 1. So that's how you do the fundamental theorem of calculus when you have trig integrals.
5 minutes, 30 seconds.
Oh, do you have to do more? Or are we good?
We're good.
Okay.